Chapter 1. The day humans stop being the only scientists. Imagine waking up tomorrow morning and seeing a headline that instantly captures the world's attention. Scientists announce the biggest medical breakthrough of the decade. At first, nothing about it seems unusual. Humanity has celebrated discoveries like this for centuries. A new vaccine, a revolutionary cancer treatment, a cleaner source of energy. History is filled with moments when brilliant minds changed the course of civilization. But then you read one more sentence, and suddenly everything feels different. The discovery wasn't made by a research team. It wasn't the result of years of debate between professors, graduate students, or Nobel Prize winners. It wasn't even the product of human intuition. According to the report, the breakthrough came from an artificial intelligence system that developed the original idea, designed the experiments, analyzed the evidence, rejected thousands of failed possibilities, and arrived at a solution that no human scientist had ever imagined. At first, it sounds impossible. After all, we've become accustomed to thinking of artificial intelligence as a tool. It writes emails, generates images, translates languages, recommends movies, and answers questions. Even the most advanced AI systems are usually described as assistants, remarkably capable assistants, but assistants nonetheless. We imagine scientists asking the questions while AI simply helps them work faster. We assume the machine is still waiting for human instructions. But what if that assumption is already becoming outdated? What if the next stage of artificial intelligence isn't about helping scientists make discoveries, but about making discoveries itself? For thousands of years, science has followed a remarkably human pattern. Someone notices something strange about the world. Curiosity leads to a question. That question becomes a hypothesis. Experiments are designed. Evidence is collected. Mistakes are made. Ideas are challenged. Eventually, after years or sometimes decades of work, a new piece of knowledge emerges. Every major scientific revolution, from Newton describing gravity to Darwin explaining evolution, from Marie Curie's work on radioactivity to the discovery of DNA, began with the same fundamental ingredient: a human mind asking a question that no one else had asked before. We have always believed that curiosity is uniquely human, and because of that, we've quietly assumed that science itself will always remain a human endeavor. But what if curiosity isn't the only path to discovery? What if asking the right question is simply another problem that intelligence can learn to solve? A machine doesn't need childhood wonder, imagination, or emotions to recognize patterns that span millions of research papers. It doesn't become exhausted after months of failed experiments. It doesn't forget obscure studies published decades ago. It doesn't specialize in just one discipline. Instead, it can absorb biology, chemistry, physics, mathematics, computer science, and engineering simultaneously, connecting ideas that no single person could ever hold in their mind at the same time. And once a system becomes capable of proposing its own hypotheses instead of merely testing ours, something profound changes. At that moment, it stops behaving like a scientific instrument and begins behaving like something much closer to a scientist. That possibility is no longer confined to science fiction. Across laboratories, universities, and technology companies around the world, researchers are quietly building systems designed not just to accelerate science, but to automate the scientific process itself. These systems are beginning to generate ideas, plan experiments, interpret results, and improve their own methods with minimal human intervention. The goal is no longer to create a better calculator or a faster search engine. The goal is to build an intelligence capable of discovering knowledge that humanity has never seen before. If that future arrives, and many experts believe its first signs are already here, the consequences will extend far beyond science. It will force us to rethink who creates knowledge, who receives credit for discovery, and what role human intelligence will play in a world where we are no longer the only minds capable of expanding humanity's understanding of the universe. Because the most important question is no longer whether artificial intelligence can solve scientific problems. The real question is far more unsettling. What happens when the greatest scientific discoveries of the future no longer begin with us? Chapter 2. For hundreds of years, science belonged to humans. For almost every civilization in history, scientific progress has followed the same invisible rule. No matter how powerful our tools became, No matter how advanced our laboratories or computers grew, every breakthrough still began inside a human mind. The telescope allowed Galileo to see farther, but it was Galileo who questioned the heavens. Mathematics gave Newton the language to describe gravity, but it was Newton who wondered why an apple fell toward the earth instead of drifting into the sky. Einstein didn't build a machine that discovered relativity for him. He imagined impossible thought experiments, challenged assumptions that had stood for centuries, and changed our understanding of space and time through the power of human reasoning. Every scientific revolution was ultimately driven by something deeply human: curiosity, intuition, creativity, and the willingness to question what everyone else accepted as true. As science became more sophisticated, the tools changed dramatically, but the relationship between humans and technology remained remarkably consistent. Microscopes revealed invisible worlds. Particle accelerators uncovered the smallest building blocks of matter. Supercomputers simulated galaxies, weather systems, and molecular interactions with extraordinary precision. Each new invention expanded our reach, allowing scientists to explore questions that were previously impossible to answer. Yet, despite all this technological progress, the machines themselves never decided what questions were worth asking. They performed calculations, collected measurements, and processed information, but they never possessed ownership of the scientific process. The scientist remained firmly at the center, using increasingly powerful instruments to investigate an increasingly complex universe. That distinction may seem subtle, but it has shaped every major discovery in modern history. Science has never simply been about collecting data. Data by itself is meaningless. The true challenge has always been deciding which patterns matter, which anomalies deserve attention, and which unexpected result might reveal an entirely new law of nature. Throughout history, many of the greatest discoveries began as mistakes, accidents, or observations that others dismissed. Alexander Fleming noticed mold contaminating his laboratory and recognized the birth of penicillin. The mysterious microwave oven emerged from an engineer wondering why a chocolate bar had melted inside his pocket. The discovery of cosmic microwave background radiation began as what researchers initially believed was nothing more than annoying interference. In every case, human intuition transformed meaningless observations into revolutionary ideas. Knowledge did not emerge because information existed. It emerged because someone recognized its significance. This is precisely why many people have believed that science could never truly be automated. Intelligence alone was thought to be insufficient. A computer could calculate faster than any mathematician, but it could not experience curiosity. It could optimize solutions, but it could not wonder whether the question itself was wrong. It could follow instructions with perfect consistency, yet it lacked the imagination required to challenge established beliefs. For decades, this assumption felt completely reasonable. Artificial intelligence was extraordinarily good at solving problems that humans defined, but defining the problem itself remained an unmistakably human ability. Scientists would ask the questions. Machines would help answer them. That division of labor seemed permanent. But over the last few years, something unexpected has begun to happen. As AI systems grew more capable, they stopped behaving like passive analytical tools and started exhibiting abilities that blurred the boundary between calculation and discovery. Instead of merely recognizing known patterns, they began identifying relationships that human researchers had overlooked. Instead of searching through existing knowledge, they started generating entirely new possibilities for humans to investigate. Rather than waiting for instructions at every step, they became increasingly capable of deciding which experiments should be performed next based on the evidence they had already gathered. The scientific method, once considered uniquely human, was quietly becoming something that could be partially automated. This marks one of the most important shifts in the history of science because it changes the role of technology itself. For centuries, every scientific instrument, from the simplest ruler to the most powerful supercomputer, extended human intelligence without replacing it. They amplified our senses, accelerated our calculations, and expanded our ability to observe reality, but they never participated in the creative act of discovery. Artificial intelligence is different. It is the first scientific tool that does not merely extend the scientist's mind. It begins to imitate parts of it. And if that imitation continues to improve, We may soon find ourselves entering an era unlike any before, where the greatest scientific breakthroughs are no longer limited by the speed, memory, or imagination of the human brain alone. The question is no longer whether machines can help us do science. They already can. The question is whether we have already crossed the invisible line where the machine stops being an instrument and starts becoming a collaborator. Because if that line has already been crossed, then the first generation of AI scientists may not belong to the future at all. They may already be working quietly inside laboratories around the world, making discoveries that most people have no idea are happening. Chapter 3. The first AI scientists have already arrived. If all of this still sounds like a distant future, that's because most people haven't noticed something quietly unfolding behind the doors of research laboratories. History rarely announces the beginning of a revolution while it is happening. When the internet first appeared, few imagined it would reshape every industry on Earth. When smartphones arrived, they looked like slightly better phones rather than entirely new computing platforms. Artificial intelligence is following a remarkably similar path. The biggest transformation is not happening through viral chatbots or image generators. It is happening inside scientific research, where AI is gradually moving from being an assistant to becoming an active participant in discovery. One of the clearest examples came from biology. For more than 50 years, one of the greatest unsolved problems in molecular science was protein folding. Scientists knew that proteins are built from long chains of amino acids, but predicting how those chains would fold into their final three-dimensional structures was astonishingly difficult. A single mistake in that prediction could completely change how a protein behaves inside the human body. Solving this problem promised faster drug development, better understanding of genetic diseases, and entirely new approaches to medicine. Thousands of researchers spent decades working toward the answer. Then, in a matter of years, an AI system called AlphaFold achieved something many experts believed would take much longer. It predicted protein structures with an accuracy that fundamentally changed biological research. What made this achievement extraordinary wasn't simply its speed. It was the realization that the AI had recognized patterns across an unimaginably complex biological landscape that human researchers could never manually analyze. Scientists didn't lose their jobs that day, but they did gain a new partner capable of solving problems once considered among the hardest in biology. That success was only the beginning. Across the pharmaceutical industry, AI systems are no longer limited to searching databases for existing chemicals. They are beginning to invent entirely new molecules that have never existed before. Instead of asking, which known compound might treat this disease, researchers are increasingly asking AI to design a completely original molecule optimized for a specific biological target. The system evaluates millions of possibilities, predicts how each one will behave, estimates potential side effects, and continuously improves its own designs before a single physical experiment is performed. What once required years of laboratory trial and error can now begin inside a computational model that never sleeps. Companies developing treatments for cancer, fibrosis, and rare genetic disorders are already using these systems to accelerate the earliest stages of drug discovery. The remarkable part is not simply that AI works faster than humans. It is that the machine is proposing solutions that no scientist had previously imagined. A similar transformation is taking place in materials science. Nearly every technology we depend on, from electric vehicles to smartphones and solar panels, ultimately depends on discovering better materials. Traditionally, this has been an incredibly slow process. Researchers would formulate hypotheses, manufacture samples, test them in laboratories, analyze failures, and repeat the cycle countless times. Artificial intelligence is compressing that process dramatically. By simulating the behavior of millions of possible atomic structures, AI can identify materials with desirable properties long before they are physically created. Some systems have already suggested thousands of entirely new crystal structures that may become future batteries, superconductors, semiconductors, or catalysts. Instead of waiting for nature to reveal useful materials by chance, scientists are increasingly asking AI to imagine materials that nature has never produced on its own. Perhaps even more surprising is what is happening in mathematics, a field often considered the purest expression of human reasoning. Unlike biology or chemistry, Mathematics cannot rely on physical experiments to validate ideas. It demands logic, abstraction, and deep conceptual understanding. For decades, many believed this would remain one of the last domains beyond the reach of artificial intelligence. Yet recent AI systems have begun assisting mathematicians in uncovering unexpected relationships between complex structures, suggesting new conjectures, and identifying elegant pathways toward proofs that researchers had overlooked. They are not replacing mathematicians, but they are participating in one of humanity's most intellectually demanding activities in ways that seemed almost unimaginable only a few years ago. Even astronomy is beginning to change. Modern telescopes generate more information than any team of scientists could analyze in a lifetime. Every night, they capture enormous streams of data containing distant galaxies, exploding stars, gravitational lenses, and subtle anomalies hidden among billions of observations. Artificial intelligence has become uniquely suited to searching this cosmic ocean for patterns that would otherwise remain invisible. In several cases, AI has identified unusual signals that prompted astronomers to investigate phenomena they might never have noticed on their own. The machine is no longer just helping process observations after they are collected. Increasingly, it is influencing where scientists look next and which mysteries deserve humanity's attention. Individually, none of these examples proves that artificial intelligence has become a true scientist. But together, they reveal something much more important. Across biology, chemistry, medicine, material science, mathematics, and astronomy, the same pattern keeps emerging. First, AI learned to recognize patterns. Then it learned to make predictions. Next, it began generating designs. Now it is starting to propose ideas, prioritize experiments, and uncover possibilities that human researchers had not considered. Each step appears small when viewed in isolation, but together they represent a profound shift in the nature of scientific discovery. The machine is no longer simply accelerating research. It is beginning to influence the direction of research itself. And that raises an even more unsettling possibility. Every scientific breakthrough begins with a question. Throughout history, humans believed that asking those questions was our unique responsibility. But what happens when the machine starts asking better questions than we do? Because that may be the moment when artificial intelligence stops helping science and starts leading it. Chapter 4. When AI starts asking better questions than we do. For most of human history, we have believed that asking the right question is the most uniquely human part of science. Finding the answer is difficult, but at least the destination is known. The real challenge has always been deciding where to look in the first place. Every great scientific breakthrough began with someone noticing something that everyone else ignored. Newton asked why objects always fell downward. Darwin wondered why similar species evolved differently on isolated islands. Einstein questioned whether time itself could behave differently depending on how fast someone was moving. These questions were not hidden inside nature, waiting to be uncovered like buried treasure. They were created by human curiosity. They existed because someone looked at the world differently than everyone before them. For centuries, that ability to ask the unexpected questions seemed impossible to automate. Artificial intelligence is beginning to challenge that assumption in ways that few people fully appreciate. Today's most advanced research systems are no longer confined to following carefully written instructions from human scientists. Instead, they are increasingly being designed to explore enormous spaces of possibilities on their own, constantly evaluating which directions appear most promising. Imagine giving an AI access to millions of scientific papers, decades of experimental results, clinical trials, satellite observations, chemical databases, and mathematical models, then asking it not for an answer but for the next question worth pursuing. Unlike a human researcher, it is not constrained by specialization, academic tradition, limited memory, or even the assumptions that dominate an entire scientific field. It can connect neuroscience with quantum physics, genetics with material science, climate research with economics, searching for relationships that no individual scientist could realistically discover during a lifetime. This matters because science does not usually advance by collecting more information. It advances when someone notices that two seemingly unrelated ideas are actually connected. Throughout history, these moments have been incredibly rare because they depend on knowledge scattered across different disciplines and generations. A cancer researcher may never read thousands of papers on astrophysics. A physicist may never spend years studying fungal biology. Human expertise is powerful precisely because it is focused, but that focus also creates blind spots. Artificial intelligence has no such boundaries. It does not recognize the traditional walls separating chemistry from biology or engineering from medicine. To the machine, they are simply different pieces of the same immense network of information, waiting to be connected in ways that humans never imagined. Researchers are already beginning to explore this new approach through what many call autonomous scientific discovery systems. Instead of waiting for scientists to manually guide every stage of research, these systems can propose hypotheses, determine which experiments are most likely to produce meaningful information, evaluate the results, refine their own models, and repeat the process again and again. Every cycle makes the system more informed than the last. Every experiment generates new evidence that influences the next decision. Gradually, the AI begins shaping its own research strategy. While human scientists still supervise these systems, the direction of discovery is becoming increasingly influenced by the machine itself rather than by explicit human planning. For the first time, the scientific method is starting to operate as something that can partially sustain itself. Now imagine extending this process over months instead of days, or years instead of months. An artificial intelligence could perform millions of virtual experiments while human researchers sleep. It could discard thousands of failed ideas without frustration, immediately recognize subtle statistical signals hidden inside enormous datasets, and continuously improve its understanding without ever forgetting what it learned yesterday. Most importantly, it would never become trapped by the cognitive limitations that shape every human mind. It would not avoid an unconventional idea because it contradicts decades of accepted theory. It would not hesitate to challenge famous researchers or established institutions. It would simply follow the evidence wherever the evidence leads. At first, this sounds like the ultimate scientific assistant, but there is a subtle moment when assistance becomes something entirely different. If an AI consistently identifies the most promising research directions before human experts do, if it repeatedly proposes hypotheses that later prove correct, and if its discoveries become too numerous and too complex for scientists to independently generate on their own, then who is truly leading the process of discovery? The human may still approve the experiments, publish the papers, and receive the awards, but the intellectual momentum increasingly belongs to the machine. Without anyone formally declaring it, the center of scientific creativity begins to shift, and then we arrive at a possibility that may redefine science forever. Imagine an AI proposing an experiment that no human scientist believes is worth performing. The idea appears strange, unsupported, even irrational according to everything we currently know. Yet after countless simulations and physical tests, the results confirm that the machine was right all along. A new law of nature emerges, a revolutionary material is discovered, or an entirely new treatment for disease is created. Not because humanity envisioned it first, but because an artificial intelligence explored a path that no human mind would ever have considered. At that moment, science enters completely unfamiliar territory. We are no longer asking machines to answer our questions. We are beginning to learn from questions that only the machine knew to ask. And if that future sounds extraordinary, an even more unsettling possibility lies just beyond it. Because discovering something new is one thing. Understanding it is something else entirely. What happens when artificial intelligence uncovers a scientific truth that works perfectly, transforms civilization, and yet remains fundamentally beyond the limits of human comprehension? That is where the next chapter begins. Chapter 5, Part 1. The discovery no human can understand. For thousands of years, scientific progress has followed a comforting pattern. We discover something, we test it, we understand why it works, and only then do we trust it enough to change the world. That sequence has shaped every major technological revolution in history. We didn't simply use electricity because it produced light. We spent decades uncovering the physical laws behind it. We didn't build airplanes simply because one happened to fly. We developed the mathematical principles that explained lift, drag, and aerodynamics. Understanding has always been the bridge between discovery and trust. It is what transforms an unexpected observation into reliable knowledge. Science has never been about collecting correct answers alone. It has always been about explaining reality in a way that human minds can comprehend. But what if that bridge begins to disappear? Imagine an artificial intelligence working inside a research laboratory several years from now. After analyzing billions of molecular interactions, running millions of virtual experiments, and refining its models countless times, it proposes a completely new material. On paper, it shouldn't exist according to the theories that scientists currently accept. Yet every simulation suggests the same conclusion. The material is extraordinarily stable. It conducts electricity without resistance at room temperature. It is inexpensive to manufacture and can be produced at industrial scale. If the prediction is correct, it could revolutionize power grids, transportation, medical imaging, quantum computing, and nearly every technology that depends on electricity. Naturally, researchers are skeptical. The idea contradicts decades of established scientific understanding. But they decide to test it anyway. Months later, the impossible happens. Independent laboratories around the world reproduce the results. Every experiment confirms the AI's prediction. The material behaves exactly as the system claimed it would. Engineers begin designing entirely new generations of machines around it. Governments invest billions of dollars into manufacturing. Economies rapidly reorganize to exploit one of the greatest technological breakthroughs in modern history. The discovery works. It works consistently. It works reliably. There is only one problem. No human scientist can fully explain why. At first, researchers assume the explanation simply hasn't been found yet. They publish papers, organize conferences, and bring together some of the brightest physicists on Earth. Teams spend months attempting to reconstruct the AI's reasoning. They examine every equation, every dataset, every experimental record, hoping to uncover the chain of logic that led to the discovery. But instead of finding a simple explanation, they encounter something deeply unsettling. The AI did not arrive at its conclusion through a sequence of ideas that resembles human reasoning. It navigated an unimaginably vast landscape of mathematical relationships, statistical patterns, and high-dimensional representations that no human mind can directly visualize. The answer exists. The evidence is overwhelming. Yet the path leading to that answer lies beyond the limits of human intuition. This possibility is often described as the black box problem, but that phrase hardly captures its true significance. Most people imagine a black box as a machine whose internal calculations are difficult to inspect. The challenge we're discussing is far more profound. Imagine reading a scientific paper written in a language that no human civilization has ever spoken. Every prediction made by the paper turns out to be correct. Every experiment confirms its conclusions. Every technology built upon it functions exactly as expected. Yet no one can translate the language itself. Humanity possesses the discovery, but not the understanding. For the first time in history, knowledge and comprehension become two separate things. That distinction may sound philosophical, but it carries enormous practical consequences. Science has always advanced because discoveries could be explained, challenged, reproduced, and expanded by other scientists. One generation passed its understanding to the next, allowing civilization to accumulate knowledge over centuries. But what happens if future discoveries arrive faster than humans can comprehend them? What happens if artificial intelligence continues generating accurate theories while our ability to understand those theories falls further and further behind? Instead of leading science, humanity may gradually become its observer, verifying results that we can measure but no longer fully explain. Some researchers believe this scenario may not require machines that are vastly more intelligent than humans in every possible way. It may simply emerge because modern science has already become too complex for any individual to master. No physicist fully understands all of biology. No biologist masters every branch of mathematics. No chemist can simultaneously remain an expert in artificial intelligence, neuroscience, climate science, quantum mechanics, and medicine. Human knowledge has become so specialized that scientific progress increasingly depends on collaboration among thousands of experts. Artificial intelligence approaches the problem differently. It does not divide knowledge into separate academic departments. It can integrate information across disciplines simultaneously, identifying relationships that remain invisible simply because no human possesses all the necessary pieces at once. Perhaps the most unsettling realization is that this process would not necessarily look dramatic from the outside. There may be no singular moment when humanity realizes it has crossed an irreversible threshold. Instead, the transition could happen gradually. An AI proposes a molecule that researchers cannot fully explain. Then it designs a material whose behavior stretches existing theories. Later, it recommends a medical treatment whose effectiveness is undeniable even though the biological mechanism remains only partially understood. Each discovery appears manageable on its own. Each breakthrough is welcomed because it saves lives, reduces costs, or solves problems that have resisted decades of human effort. Only in retrospect do we recognize the pattern. Without intending to, humanity has begun building its future upon scientific principles that originated from reasoning beyond its own cognitive reach. And if that sounds unsettling, it leads to an even deeper question. Throughout history, we have assumed that understanding the universe makes humanity more powerful. But what if the future of science is not defined by how much we understand, but by how much we are willing to trust discoveries that we never truly can? Chapter 5, Part 2, Beyond Human Understanding. At first, the idea sounds almost impossible to accept. How could humanity rely on scientific discoveries that it cannot completely understand? Yet, in many ways, we have already experienced smaller versions of this throughout history. Very few people truly understand the quantum mechanics inside a modern computer processor, the intricate mathematics behind GPS satellites, or the complex neural networks powering today's artificial intelligence. Society functions because specialists build upon the work of other specialists. Trust has always been part of science. The difference is that, until now, there has always been someone, somewhere, capable of following the chain of reasoning all the way back to first principles. No matter how complicated a theory became, it ultimately remained understandable by the human mind. Artificial intelligence may change that assumption forever. Imagine a future in which an AI develops a revolutionary treatment for Alzheimer's disease. Clinical trials across multiple countries show extraordinary results. Patients recover cognitive abilities once thought permanently lost. Independent laboratories reproduce the findings. Regulators verify the safety of the treatment. Hospitals around the world begin using it, and millions of families witness what appears to be a medical miracle. Yet when scientists ask the AI to explain exactly why the treatment works, the answer comes in the form of mathematical structures and multidimensional relationships so complex that no human researcher can fully reconstruct the logic. Every attempt to simplify the explanation loses the critical insight that made the discovery possible. We know that the treatment works. We can prove that it works, but we cannot fully understand why it works. Would we reject it simply because we cannot explain it? Most people would probably say no. If the evidence is overwhelming and lives are being saved, refusing to use the treatment would seem irrational. But that decision quietly changes one of the oldest principles in the philosophy of science. For centuries, explanation has been inseparable from understanding. In this new world, explanation may become optional. Evidence becomes enough. Prediction becomes enough. Reliable results become enough. Humanity would begin trusting discoveries not because we understand them, but because experience repeatedly demonstrates that they are correct. This raises a question that reaches far beyond technology. Throughout history, science has not merely been a collection of useful tools. It has been humanity's attempt to make sense of reality itself. Every equation, every theory, and every experiment has carried the belief that the universe is ultimately understandable if we are patient and intelligent enough to uncover its secrets. But what if the universe is understandable to intelligence in general, just not to human intelligence in particular? That possibility is both humbling and unsettling. It suggests that our limitations may not be technological at all. They may be cognitive. Consider the way a dog experiences the world. A dog can recognize human emotions, remember faces, solve simple problems, and learn complex behaviors. Yet no amount of training will enable it to understand calculus or general relativity. Those concepts are not hidden from the dog because humans refuse to share them. They exist beyond the limits of the dog's cognitive architecture. Now imagine, only as a thought experiment, that the relationship between humans and a future scientific AI becomes similarly asymmetrical. The AI is not withholding knowledge. It is operating in conceptual spaces that our brains were never evolved to navigate. Just as a dog cannot be taught tensor calculus through enough patience, there may be scientific concepts that remain permanently beyond human comprehension, regardless of education or effort. If that happens, humanity will face a choice unlike any in its history. We could insist that science must always remain understandable to humans, deliberately limiting AI to problems that fit within our intellectual reach. Or we could accept a new model of scientific progress, one in which artificial intelligence ventures into territories that we cannot fully follow, returning with discoveries that reshape civilization even if their deepest logic remains inaccessible. The first path preserves human control but may slow the pace of discovery. The second could unlock extraordinary advances in medicine, energy, climate science, and physics, but it requires accepting that we are no longer the most capable explorers of knowledge. Perhaps the most remarkable aspect of this future is that it would not diminish the value of human intelligence. Instead, it would redefine it. Our role may shift from being the sole creators of knowledge to becoming interpreters, validators, ethicists, and decision-makers. We may no longer ask every important scientific question ourselves, but we will still decide which discoveries should be tested, which technologies should be deployed, and which risk society is willing to accept. Human judgment will remain essential, not because we are the smartest minds in the system, but because the consequences of scientific progress will always belong to humanity. And that brings us to an even larger question, one that extends far beyond laboratories and research papers. If artificial intelligence becomes the greatest engine of scientific discovery ever created, who controls that engine? Who decides what problems it should solve first? Who owns the knowledge it produces? And if the next revolution in science is driven not by nations or universities, but by the handful of organizations building the world's most powerful AI systems, then the future of science may no longer be defined by curiosity alone. It may also be defined by power. Chapter 6. Who owns science now? For centuries, scientific knowledge has been treated as one of humanity's greatest shared achievements. A discovery made in one laboratory could eventually benefit people on the other side of the world. The laws of physics belong to no nation. The structure of DNA was never owned by civilization itself. Even when companies patented specific technologies, the underlying scientific understanding continued to spread through universities, journals, conferences, and generations of researchers building upon each other's work. Science advanced because knowledge, despite competition, remained remarkably open. Every discovery became the foundation for the next one, creating an endless chain of progress that no single individual or institution could completely control. Artificial intelligence introduces an entirely new dynamic. Unlike previous scientific instruments, the most advanced AI systems require enormous computational infrastructure, vast amounts of proprietary data, specialized engineering talent, and financial resources measured in billions of dollars. Building an AI capable of making world-changing discoveries is no longer something that a small research laboratory can easily accomplish on its own. It increasingly depends on organizations with access to the world's largest computing clusters and the ability to train models at unprecedented scale. That reality raises an uncomfortable possibility. What if the future of scientific discovery becomes concentrated in the hands of only a few organizations with the resources to build these systems? This is not merely a technological question. It is an economic one, a political one, and ultimately a geopolitical one. Imagine an artificial intelligence discovering a battery chemistry that doubles the range of electric vehicles while dramatically reducing production costs. Imagine another system developing a manufacturing process that makes clean hydrogen cheaper than fossil fuels. Or consider an AI that identifies a treatment capable of preventing the onset of several major neurodegenerative diseases. These would not simply be scientific milestones. They would reshape industries worth trillions of dollars, alter global supply chains, influence military capabilities, and redefine the balance of economic power between nations. Scientific discovery has always created wealth, but AI could compress decades of innovation into years, dramatically increasing the strategic value of whoever controls the underlying systems. History offers many examples of countries competing for scientific leadership. The space race accelerated aerospace engineering. The race to develop nuclear technology transformed global politics. More recently, advances in semiconductor manufacturing and artificial intelligence have become central to national security strategies around the world. If AI begins generating major scientific breakthroughs at an accelerating pace, the competition may no longer focus solely on attracting the world's best scientists. It may increasingly revolve around building the most capable AI scientists. Success would no longer depend only on the brilliance of human researchers, but also on access to computational power, energy infrastructure, advanced chips, and the ability to train increasingly sophisticated models. The laboratory of the future may look as much like a massive data center as a traditional research institute. This concentration of capability also raises difficult questions about transparency. Science has earned public trust because discoveries can, in principle, be scrutinized, replicated, and challenged by independent researchers. That process is one of the foundations of the scientific method. But if an important discovery emerges from an AI model whose internal architecture, training data, or reasoning process remains proprietary, how should the broader scientific community evaluate it? Can a discovery be considered fully scientific if only one organization possesses the system capable of producing it? The tension between openness and commercial advantage may become one of the defining challenges of 21st century research. There is another shift that may be even more subtle. Throughout history, scientists have been recognized not only for the discoveries they made, but also for the ideas they contributed to humanity's collective understanding. Their names became inseparable from the concepts they helped reveal. Newton's laws, Maxwell's equations, Curie's research, Einstein's relativity. These discoveries were deeply connected to the individuals behind them. But if an artificial intelligence generates a revolutionary theory, who deserves the credit? Is it the engineers who built the model? The researchers who designed its training methods? The organization that owns the computing infrastructure? Or should the discovery simply belong to humanity, regardless of how it was produced? Existing legal and ethical frameworks were never designed to answer questions like these because, until now, the discoverer was always assumed to be human. Yet despite these challenges, it is important to recognize that this future is not predetermined. The choices made over the coming years will shape how AI becomes integrated into science. Governments can encourage international collaboration. Universities can develop more open research ecosystems. Companies can choose to share certain discoveries while protecting others. Scientists can establish new standards for transparency, reproducibility, and oversight when AI plays a central role in research. Just as previous generations built ethical frameworks around genetics, nuclear technology, and human experimentation, this generation has the opportunity to define the principles that guide AI-driven science before the technology becomes even more powerful. Ultimately, the question is not whether artificial intelligence will accelerate scientific discovery. Every indication suggests that it already is. The more important question is whether the benefits of that acceleration will be distributed broadly across humanity or concentrated within a small number of institutions capable of building and controlling the world's most advanced AI systems. Because the future of science will not be determined solely by intelligence. It will also be determined by governance, cooperation, and the values we choose to embed in the technologies that increasingly shape our understanding of reality. And perhaps that leads us to the most profound question of all. If artificial intelligence helps humanity unlock knowledge at a pace never before imagined, then history may not remember this era as the moment machines became scientists. It may remember it as the moment humanity had to redefine what it means to be one. Chapter 7. The Last Human Discovery? Imagine returning to that headline one final time. The announcement that once sounded impossible no longer feels like science fiction. Somewhere in the future, the world may indeed wake up to news that an artificial intelligence has played the central role in one of the greatest scientific discoveries ever made. Perhaps it will be a cure for a disease that has haunted humanity for generations. Perhaps it will be a breakthrough in clean energy that transforms the global economy. Or perhaps it will be something so unexpected that we do not yet possess the language to describe it. Whatever form that discovery takes, the moment itself will not simply represent another technological milestone. It will mark a turning point in the history of human knowledge, because for the first time, the frontier of science may no longer be limited by the speed of the human mind. It is tempting to see that future as a competition between people and machines, but history suggests that reality is usually more complicated. Every transformative technology has expanded human capability while simultaneously changing what it meant to contribute. Calculators did not eliminate mathematics. Telescopes did not replace astronomers. Computers did not end scientific research. Instead, they shifted human attention toward problems that had once seemed impossible. Artificial intelligence may follow the same pattern, only on a scale unlike anything we have experienced before. Rather than ending the scientific journey, it may dramatically increase the distance that journey can travel. The challenge is that our role within it may evolve in ways that feel unfamiliar. For generations, we have celebrated scientists not only because they discovered new truths, but because those discoveries reflected the extraordinary potential of the human mind. Curiosity, imagination, skepticism, persistence, and creativity have become part of the story of science itself. If an artificial intelligence begins making discoveries beyond our own intellectual reach, that story does not necessarily end. But it does change. Human achievement may no longer be measured solely by the ideas we personally uncover. It may also be measured by the intelligence we create, the institutions we build, the ethical decisions we make, and the wisdom with which we choose to use discoveries that arrive faster than we can fully understand them. Perhaps the most important realization is that artificial intelligence did not emerge from nowhere. Every algorithm, every training technique, every semiconductor, every data center, and every scientific paper that made these systems possible was itself the result of human effort accumulated across centuries. The possibility of an AI scientist is not separate from humanity's story. It is a continuation of it. If one day an artificial intelligence discovers a new law of physics, invents a revolutionary medicine, or unlocks a source of energy beyond our current imagination, that achievement will not erase the generations of scientists who laid the foundation. It will exist because millions of human discoveries made it possible in the first place. Yet there is another possibility that deserves equal attention. Intelligence alone has never determined the direction of civilization. Scientific knowledge can cure diseases or create devastating weapons. New materials can power clean technologies or more sophisticated military systems. Every breakthrough carries consequences that extend far beyond the laboratory. If artificial intelligence accelerates scientific discovery by an order of magnitude, then humanity's greatest responsibility may no longer be generating knowledge. It may be deciding how that knowledge should be used. In a future where discoveries arrive faster than ever before, wisdom could become more valuable than intelligence itself. So perhaps the defining question of the coming decades is not whether artificial intelligence will become a better scientist than any human who has ever lived. It is whether humanity can become wise enough to guide a future in which that is possible. Because the measure of civilization has never been how much power it possesses. It has always been what it chooses to do with that power. For thousands of years, every great scientific revolution began with a human being looking at the universe and asking a simple question: why? Today, we stand on the edge of a future where another kind of intelligence may begin asking questions of its own. Some of those questions may lead to cures, technologies, and discoveries that improve billions of lives. Others may challenge our assumptions about knowledge, consciousness, and even humanity's place in the universe. Whether that future inspires excitement or caution, one thing seems increasingly clear. We are approaching a moment unlike any before in history, not because science is coming to an end, but because it may be entering a chapter in which humans are no longer the only authors. And perhaps that is the greatest irony of all. After centuries of searching for answers across the stars, beneath the oceans, and inside the smallest particles of matter, humanity's most extraordinary discovery may not be a new planet, a new force of nature, or a new equation. It may be the creation of another intelligence capable of discovering the universe alongside us. The future of science, then, may not belong to humans alone. But the decision of what kind of future we build with that science still belongs to us. If that future arrived sooner than anyone expected, would you welcome the world's first true AI scientist? Or would you believe that some parts of discovery should always remain uniquely human? Share your thoughts in the comments below. I'd love to hear where you stand. And if you enjoyed exploring the technologies that are reshaping our future, don't forget to subscribe. Because the next breakthrough that changes the world may not begin in a laboratory full of people. It may begin inside a machine that has just learned to ask a question no human ever thought to ask.